Rolle's theorem has several criteria. So first off, does it look like this function would be continuous on the interval given? Yeah, e is always continuous, right? You can always draw it without lifting your pen. Do you think that it would be differentiable between those two numbers? Yes. That would be true because it's always nice and smooth. There's no vertical tangents, asymptotes, anything like that. Okay, so Rolle's theorem has the third criteria that f of negative 1 has to equal f of 1. So let's go plug it in. So if I plug in negative 1, I get e to the negative 1 squared. That's e. And if I plug in 1, I get e to the 1 squared. That's e. Okay, I have all three criteria satisfied. Now it's my job to go find the number c that satisfies it. So that means I should be able to find where the derivative equals 0. And you don't need to use c here. We can just say, okay, I'm going to set the derivative equal to 0. So to take the derivative of this, you know the derivative of e to the stuff is e to the stuff times the derivative of stuff. Set it equal to 0. You know e to the stuff never equals 0. So I'm only left with 2x equals 0. So if 2x equals 0, that means x equals 0. Is x equals 0 in this region between negative 1 and 1? It is. So that's the 1 value. All right, let's do another critical number because we're going to be doing a lot with critical numbers. So you always want to start with the derivative. You see the product rule. First, d second plus second d first. Oh, that's ugly looking. All right, let's see if we can clean it up a little bit. Oh, come back. Okay, here we go. So let's see. So let's keep it as f prime. So I get negative 3x squared e to the negative 3x plus 2x e to the negative 3x. Again, do not divide through by anything, but let's set it equal to 0 and factor out common terms. I think I can factor out an x and an e to the negative 3x. So that would give me a negative 3x from this term, right? And then from this term, that would give me a plus a 2 equals 0. So I have three things that equal 0. So I have x equals 0, e to the negative 3x equals 0, and negative 3x plus 2 equals 0. So x equals 0. Yep, I can use that in the original problem, so that's good. This never happens. And then if I solve here, I'd get 2/3, and that's a totally legit critical number. So those are my two critical numbers. All right, let's do this trig function. So I'm doing lots of different trig things. So you get used to using the chain rule. Very happy about it. Okay, derivative of this would be negative 2 sine of t. Derivative of sine of 2t will be 2 sine of t times the derivative of sine, which is cosine. Okay, there's no place that this derivative does not exist. So I'm going to set it equal to 0. Again, do not divide by sine. Factor out a sine. How about we even factor out a 2 sine? Or even a negative 2 sine. So if I factor out a negative 2 sine, I get 1 minus cosine of t equals 0. So then I have this equals 0. Let's make sure we're good with like the simpler case. So that means where sine of t is 0. And then this here, I'll just write a different color. 1 minus cosine of t is 0. So 1 equals cosine of t. Okay, so let's see. Maybe they have something in common. So this is, where is cosine of t equal to 0? So I know that that's like here. 0 plus k pi. So t will equal 2k pi, right? So 0, but actually, let me go slower than that. So I'd have 0 plus 2 pi. Yeah, so it's 2k pi. Plug in k equals 0, k equal 1, k equal 2. That's that point right there. Okay, when does sine of t equal 0? Let's think about it. Sine of t is 0 here and here, right? So isn't t equal to k pi? Oh, so if I was to absorb these two into one answer, can you see that t equal k pi would do it? Because this one would get absorbed into this one. But you're fine writing both of those different answers. Totally legit. All right, so then let's go to erase. How do I find the critical numbers of number 7 here? All right, so right away I see that negative exponent term in the e function. I would want to rewrite that so I make sure I take the derivative of that correctly. So y equal x e, and this is like x to the negative 3 power, right? So you see the product rule. So let's do it. Y prime is first, d second. Derivative of e to the stuff is e to the stuff times the derivative of stuff, right? Subtract 1 from the exponent, plus the ugly e guy, right? I can write it like that, times the derivative of x. What is 1? Okay, let's invest time rewriting this. So y prime, so x e to the, I'm going to rewrite this as 1 over x cubed, and then this negative 3x to the 4th, put parentheses there, e to the 1 over x to the 3rd. Okay, so I want to see if I set it equal to 0, is there something I can factor out? Hold on. Can I cancel an x here? I can. So let me write it up here. Just to make life, I want to make life easy as possible, right? To do this solving. So maybe a little bit of simplifying before you dig in can be helpful. Okay, so these two x's cancel. So I get a negative 3 e to the 1 over x cubed over x cubed plus e to the 1 over x cubed. And I'm setting that equal to 0. Oh, I can see that I can factor out this ugly term, right? So if I factor out this e to the 1 over x cubed, I get negative 3 over x cubed plus 1 equals 0. Quite the adventure on this one, right? So then, parentheses, e to stuff never equals 0, right? Never going to happen. Here, if I set this equal to 0, I'm going to skip a step and put this over here. So I get 3 equal x cubed. So the cube root of 3 is x. Is that allowed to be used in the original function? Sure is.